Explain how capacitors work in the circuit diagram by making an analogy to water flowing in pipes. Let's first look at an actual circuit, a DC circuit. Let's keep in mind that a capacitor is two metal plates separated by an insulative material or a non-conducting material. And let's keep in mind that capacitors are used to store charge. So we plug in our battery to our circuit, positive terminal here, negative terminal here. The positive terminal here attracts the negative charges in the metal plate and the metal wire. So it pulls the electrons away. The negative charges are attracted to the positively charged battery terminal, opposites attract. And as they're getting pulled away from this metal, they're leaving positive charges in their wake. So this gets positively charged. The electrons get pulled through this positive terminal, spit out the negative terminal. They start to build up on our other metal plate and thus generating a negatively charged plate. And these charges are actually creating an electric field between each other. They want to recombine with one another, but they can't because the insulator is preventing them from reaching each other. So as the amount of electrons over here runs out, as the amount of electrons that can be pulled from over here runs out, your capacitor is said to be fully charged. So we see quantitatively how for any given voltage supplied by some power source, the amount of Q, charge you can store, goes up with the amount of capacitance, which is your measure of a capacitor. So let's go to our water diagram. So now we have pipes filled with water. We have a pump, which is our battery. It pumps through water this side and spits it out this side. The water is the electrons. Comes through, and it hits our capacitor represented by an elastic membrane. That elastic membrane stretches out as more water is pressed into it. The more water or more electrons results in our negatively charged side, and the less water over here represents our positively charged side. So a good capacitor can be thought of as a good rubber band. The farther you can stretch it out, the more potential energy you can store in that rubber band. The farther this rubber membrane stretches out, the more water or the more electrons you can fit. The more charge you can fit, the more energy you can fit. Thank you.